Article 422.31b of the National Electrical Code addresses the disconnecting means for appliances. Specifically, it focuses on appliances that are not within sight of the distribution panel. In the context of a residential water heater, if the water heater is located such that it's not visible from the electrical panel that supplies it, a specific disconnecting means is required to ensure safety during maintenance or repair. The primary requirement is that the disconnecting means must be capable of being locked in the open position. This is to prevent accidental re-energization of the circuit while someone is working on the water heater. A lockable breaker satisfies this requirement. By installing a breaker lock, a qualified individual can physically secure the breaker in the off position, ensuring that the circuit remains de-energized. This addresses the concern of the water heater being out of sight from the panel, as the lock provides a positive means of preventing the circuit from being turned back on remotely. The intent is to enhance safety. Article 424.19 deals with disconnecting means for heating equipment, specifically addressing air handlers. Similar to the requirements for water heaters, if an air handler is not within sight of its supply panel, a disconnecting means capable of being locked in the open position is required. A lockable breaker again can fulfill this requirement. This ensures that during maintenance or servicing of the air handler, the electrical supply can be positively secured in the off position. This prevents the air handler from being accidentally turned on, which could create a hazard for the person working on it. The requirement for a lockable disconnecting means is crucial in situations where the equipment is out of sight from the panel. The electrician working on the air handler would need to walk to another room or floor to switch the breaker off. Without a lock, someone could inadvertently turn the breaker back on, not knowing someone is working on the equipment. The lock provides a visual and physical assurance that the circuit is de-energized. In both cases, the NEC emphasizes the importance of safety through the use of lockable disconnecting means when appliances or heating equipment are not within sight of their respective electrical panels. This approach allows electricians and other qualified individuals to confidently work on these systems without the risk of accidental electrical shock or equipment malfunction. The NEC guidelines typically call for the disconnecting means to be readily accessible to the user, but not necessarily at the location of the panel. This accessibility ensures that in an emergency or during routine maintenance, the power can be quickly and safely shut off. Furthermore, the NEC specifies that the disconnecting means should clearly indicate whether it's in the open or closed position. This indication provides a clear visual reference for anyone working on or near the equipment, confirming the status of the electrical supply. For example, a breaker handle in the off position secured with a lock provides a readily understandable indication that the circuit is de-energized. In practice, the installation of lockable breakers is relatively straightforward. Breaker locks are readily available from electrical supply vendors and come in various designs to accommodate different types of breakers. The installation typically involves attaching the lock to the breaker handle in such a way that it prevents the handle from being moved to the on position. The lock should be robust and designed to withstand typical environmental conditions, ensuring that it remains functional over time. When selecting a lockable breaker and lock combination, it's important to ensure that it is compatible with the specific type of breaker being used. Different breakers may have different handle designs requiring different types of locks. It's also important to consider the amperage rating of the breaker and ensure that the lock is appropriately sized for the application. Some jurisdictions may have additional requirements or interpretations of the NEC guidelines. It's always recommended to consult with local electrical inspectors or other qualified professionals to ensure compliance with all applicable codes and regulations. They can provide valuable insights into specific requirements in the local area and ensure that the installation meets all safety standards. In summary, the use of lockable breakers for residential water heaters and air handlers that are not within sight of their respective electrical panels is a critical safety measure mandated by the National Electrical Code. This requirement ensures that qualified individuals can safely perform maintenance or repairs on these systems without the risk of accidental electrical shock or equipment malfunction. By adhering to these guidelines, electricians and homeowners can help create a safer electrical environment. Now, let's consider some specific scenarios and related details to provide a more comprehensive understanding. Firstly, let's explore the specific requirements related to the type of disconnecting means. The NEC doesn't explicitly require a specific type of disconnecting means, but it emphasizes that it must be capable of being locked in the open position. This means that while a lockable breaker is a common and convenient solution, other types of disconnecting switches that meet the locking requirement are also acceptable. For instance, a fused disconnect switch located near the appliance and capable of being locked would also satisfy the code. The key is that the disconnecting means provides a positive and reliable way to energize the circuit and prevent it from being inadvertently re-energized. Secondly, let's discuss the accessibility requirements. The NEC requires that the disconnecting means be readily accessible. This means that it must be located in a place where it can be easily reached and operated without the need for tools or special equipment. The intent is to ensure that in an emergency, the power can be quickly shut off to prevent further damage or injury. The disconnecting means should not be obstructed by obstacles or located in a locked or inaccessible area. Thirdly, let's address the labeling requirements. The NEC requires that the disconnecting means be clearly labeled to indicate its purpose. This labeling helps to identify the specific appliance or equipment that the disconnecting means controls. The labeling should be durable and legible, ensuring that it remains readable over time. This is particularly important in situations where there are multiple disconnecting means in close proximity, as it helps to avoid confusion and ensures that the correct circuit is energized. Fourthly, let's examine the overcurrent protection requirements. The NEC requires that the circuit supplying the water heater or air handler be protected by an overcurrent device, such as a circuit breaker or fuse. The overcurrent device should be sized appropriately to protect the circuit and the appliance from overloads and short circuits. The overcurrent device should be located in the electrical panel and should be readily accessible. It's important to ensure that the overcurrent device is properly installed and maintained to ensure that it functions correctly in the event of an overcurrent condition. Fifthly, let's consider the grounding requirements. The NEC requires that the water heater and air handler be properly grounded to provide a path for fault current to return to the source. The grounding conductor should be sized appropriately and should be securely connected to the appliance and the electrical panel. Proper grounding helps to prevent electrical shock hazards and ensures that the overcurrent device will trip in the event of a ground fault. Sixthly, let's discuss the bonding requirements. The NEC requires that all metal parts of the water heater and air handler that are likely to become energized be bonded together to create a low impedance path for fault current. This bonding helps to minimize the voltage between different metal parts and reduces the risk of electrical shock. The bonding conductor should be sized appropriately and should be securely connected to the metal parts. Seventhly, let's address the voltage drop requirements. The NEC recommends that the voltage drop in the circuit supplying the water heater or air handler should not exceed 3% at the furthest outlet. Excessive voltage drop can cause the appliance to operate inefficiently and can shorten its lifespan. The voltage drop can be minimized by using appropriately sized conductors and by keeping the length of the circuit as short as possible. Eighthly, let's examine the wiring methods. The NEC specifies the acceptable wiring methods for connecting the water heater and air handler to the electrical panel. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and non-metallic sheaths cable. The wiring method should be appropriate for the environment and should be installed in accordance with the NEC requirements. Ninthly, let's consider the clearances around electrical equipment. The NEC requires that there be adequate clearances around electrical equipment to allow for safe access and maintenance. The clearances should be maintained free of obstructions and should be sufficient to allow for the removal and replacement of equipment. Tenthly, let's discuss the importance of proper installation and maintenance. The NEC requires that all electrical work be performed by qualified individuals and that it be installed in accordance with the code requirements. Proper installation and maintenance are essential for ensuring the safety and reliability of the electrical system. Regular inspection should be performed to identify any potential problems and to ensure that the equipment is functioning correctly. Now let's delve into some additional details. When dealing with a 240 volts water heater, remember that it typically requires a double pole breaker. This means that the breaker occupies 2 slots in the electrical panel and disconnects both hot wires supplying the appliance. The amperage rating of the breaker must match the requirements specified by the water heater manufacturer. Oversizing the breaker can be dangerous, as it might not trip in the event of a fault, potentially causing damage or a fire. Undersizing the breaker can lead to nuisance tripping, which can be inconvenient. For air handlers, the disconnecting means should be readily accessible. This means that it should be located within sight of the equipment, or it should be capable of being locked in the open position. The intent is to ensure that anyone working on the equipment can quickly and easily energize it. The disconnecting means should be clearly labeled to indicate which air handler it controls. This helps to avoid confusion and ensures that the correct equipment is energized. Additionally, the grounding electrode conductor plays a vital role in ensuring electrical safety. It connects the equipment grounding system to the grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent device and prevent electrical shock hazard. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. It's essential to ensure that the grounding electrode conductor is properly sized and installed to provide effective grounding. The equipment grounding conductors, on the other hand, connect the non-current carrying metal parts of the equipment to the grounding system. These conductors provide a path for fault current to return to the source in the event of a ground fault. The equipment grounding conductors should be sized appropriately and should be securely connected to the equipment and the grounding system. It's also worth noting that if SI, or arc fault circuit interrupters, have become increasingly common in residential electrical systems. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs can detect arc faults that standard circuit breakers might not detect. They provide an extra layer of protection against electrical fires. Some jurisdictions now require SIs on circuits that supply certain types of appliances, such as water heaters and air handlers. It's important to check the local electrical codes to determine whether SI protection is required in the specific application. Surge protection is another important aspect of electrical safety. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes, utility switching, or other electrical disturbances. Voltage surges can damage or destroy sensitive electronic equipment. SPD divert the surge current away from the equipment, protecting it from damage. SPD can be installed at the service entrance or at individual branch circuits. They are a valuable addition to any electrical system, particularly in areas that are prone to lightning strikes or other electrical disturbances. Moreover, when working with electrical panels, safety should be a top priority. Always energize the circuit before working on it. Use a voltage tester to verify that the circuit is energized. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, consult a qualified electrician. Electrical work can be dangerous, and it's always better to be safe than sorry. Proper torque is also crucial for making reliable electrical connections. Use a torque wrench to tighten connections to the manufacturer's specifications. Over-tightening connections can damage the terminals, while under-tightening connections can lead to loose connections, which can cause overheating and fires. It's important to use the correct torque for each type of connection. Always consult the manufacturer's instructions for the recommended torque values. Finally, remember that the NEC is a living document that is updated every 3 years. It's important to stay up to date with the latest changes to the code to ensure that your electrical installations are safe and compliant. Consider attending training courses or seminars to learn about the latest code requirement. Consulting with a qualified electrical inspector can also help to ensure that your installations meet all applicable codes and regulations. So, in conclusion, complying with Article 422.31b and 424.19 TWA by using lockable breakers for out-of-sight water heaters and air handlers is a crucial safety measure.